In the email that I sent letting you know this video is posted, I also put a link to the questions. So all the ones that are highlighted are ones that we're going to go through in this video. So for this number 6, we're using this graph in order to answer for number 6 and for number 7. So for number 6, it says, which line has a slope of -3? So right away, I can cross out this line M because it's a positive slope. If we put the person on the left-hand side, they're walking uphill. I can also cross out this line N because, once again, it is positive. So I know it's down to K or J. And from here, what we need to do is we need to look to see where does this graph cross at the corner of those boxes, because it means that it is a whole number. So from this one, it's crossing through the origin and also here. So in order to get to the origin, we're going down 1, 2, 3, and to the right 1. So my change in y was down 3. My change in x was right 1. So this is -3 because -3 over 1 is -3. So in this case, k does have a slope of -3. And since it doesn't say that there could be multiple, it says which line. That means that we know there's only one right answer. So I'm not even going to go through and find j slope. And it says, what is the slope of line M? So for M, this is this line here, this green one I just highlighted. Now I'm going to get rid of that line because we're going to have to find it. So in order to find the slope, I'm looking to see, well, here it passes through the corner of both boxes. And the reason why we're looking at that is because, once again, it guarantees its whole numbers in both ways. So now I'm just going to count down 1, 2, 3, 4. So it went down 4, so that's -4. And then to the left, 1, 2. And that means to the left, -2. If I count it from this origin up, I'm going 1, 2, 3, 4. So it would have been a 4. And I'm going right 2, which, if you notice, a negative divided by negative is still positive. So regardless of which way you count, you're still going to get the same slope. And this -4 over -2 is equal to a +2, and 4 over 2 is also equal to a +2. So the slope for this line M is equal to 2. And we're just literally counting up and over. Now, if you pick this point, and you could have picked this point, and if you did that, you're counting down 2 and over 1. So you see that's still going to give you a +2 slope, or up 2 and over 1, and it's still going to give you a +2 slope. I just happen to see this point here where it intersected in both of the corners first. All right, for this number 9 and for number 11, when you're doing these, we're going to learn an actual formula how to do this. But for now, you guys could have just approximated where they were on a graph. So this first one is 2 hours. The next one is 4 hours. And at 2 hours, it's at $80. So we know that this is at 80. And then at this other one at 4, it's at 110. And we know that we would count up and over to get to this point. So if I'm counting up, well, what I would have to count to get from 80 to 110 is 30. So that means my change in y is 30. And then to get to this point, I'm counting over 2. So my change in x is 2. And 30 divided by 2 is 15. So that would be our answer for this. For this one here, there are going to be questions like this on your test. But just so you know, these ones are not exceeding. But they aren't necessarily counting just yet. It's seeing based on how we've done slopes, if you guys would able to apply what we did in this way. And then we're going to learn formulas to be able to do this a little bit more direct. But remember, the rate of change is our slope. So calculate the slope. So same thing. I have these x values. So I'm just going to approximate where these x values would be on the graph. So if at 7, I'm at 4. Well, the next point at 14, I'm at 1. So then I know I'm going down 3 to get to that y, that next 1 value. So that means I'm going down 3. And then I'm going to the right 7. Well, this can't reduce or simplify at all. So our final answer is -3 over 7. And once again, without the formula, I'm just seeing if you guys are able to, because we have done our slopes on a graph. So I'm seeing if you guys are able to visualize how this will look on a graph. And then we're going to learn how to do it with the actual formula. All right, so for 13, it says the equation represents the distance y a second object b moves over time. X, what is the unit rate? Well, we know it's y is equal to mx plus b. And in these specific ones, we're looking at proportional relationships. So it's really just y is equal to mx. And the unit rate, and as it says in slope in parentheses, remember, we can refer to our slope as a unit rate, the rate of change, our slope, constant variation, you guys learn it as well. So in this case, it's a number that's being multiplied to our variable. So it's 9.5 times x. So our slope is 9.5. Typically, we don't write them as decimals, but if you did, as long as it's the right number, you would still be getting it right. Which object is moving? Which moving object A or B is moving at a faster rate? So we have to do that number 12 in order to solve for number 14. Well, here I see that this point is going through the corner. So I'm going up 15. So my change in y is 15. And I'm going over to 1, 2. So my change in x is 2. Well, this slope is 15 over 2. But since the other one's put in decimals, I'm going to say it's 7.5. All right, so now if it's which one is moving faster, well, 9.5 is greater than 7.5, so this would actually be a lot steeper, not a lot, but it would be steeper as a graph, meaning it's moving at a faster rate. So for this one, object B is moving faster because it has a slope that is greater than the slope of object A. All right, so same thing, this rate of change question here, it's just seeing, can you visualize this on a graph? So I'm just approximating this. I'm not actually graphing it. It's just helping me think about how it's going to count up and over. So when my x is 1, my y value is 15. And when my x is 2, my y value is 30. So if I were to, on a graph, have this to visualize, I can count up 1, 2, 3, 4. I would count up 15. And since I'm going up, it's a positive 15 for y. And then I'm going 1 over for x, which is then means I'm moving 1 to the right. So it's 15 over 1 or just 15. Once again, we are going to learn a formula for this, but for now, I was just seeing, can we visualize how we've done this before we start applying any formulas to it? All right, so for this one, number A, it says find the slope of the graph. So we need to look where it crosses in that corner. And this one, although it's like a thick line, it's crossing in corner for all of them. So to get from this original point that we have to the new point, we're going up 1, but we're not counting by 1 with our y. Every time that we move up our vertical axis, you see they're counting by 100. So our change in y is actually 100. And then when we move 1 unit over to the right, we are counting by 1s there. So our change in x is 1, and 100 over 1 is equal to a positive 100. And now these questions says, what does it represent? It means in the context of this problem, like what is it actually telling us? So if this is Brady's savings account, and this is the number of dollars that he's saving, and this is the number of months, well, that means that he is saving $100 for every 1 month. So what this is telling us is how much money he's saving per month. So he's saving $100 per month, right? So when we say like, what does it mean? It's saying like, well, you have to read and interpret the graph. What are the y and x axis? And that's why it's important to put it as a unit rate, because once we do this, we're comparing it to 1, so it allows us to easily tell that story. How much did Brady deposit when he opened the account? Well, that would be his starting point, right? Because we see that it's counting up and over at the same rate. So this initial starting point is where he started. That's his y-intercept. So he initially put in $300 when he opened up this account. And then from there, you can see he's saving $100 a month by the slope. At this rate, how much money will Brady have in his account after 15 months? Well, for this, we don't see 15 on the graph, so I can't just read the graph. But I know he's saving $100 per month, so I can do 15 times 100. And that means that he, after 15 months, he would have saved $1,500. And he started at 300 because that's where its starting point was here. So he had that 300 he initially put in. So 1,500 plus 300 is $1,800 is what we would expect him to have if he stayed on the same path. All right, so for the next one, it says if Brady deposited $500 to begin with, but continued to deposit the same amount in each month, what would his graph look like? Well, it would be almost identical to this, except for everything would be just moved up, just 2 units. So here, he would start at 500 instead of starting at 300. And then the slope is still 100, so it would just look like this. Now, I don't have a straight edge I can use, so yours would be a little bit better. So it will just look like that, where it's just everything is translated up $200 because he's now starting out with 200 more in the beginning. And it says if Brady deposited 300 initially, which we know they did based on the graph, but spent it all in 5 months, show this on the graph. So now the difference is with this black line, it goes to 12 months. Well, now here, he would then be spending it all in 5 months. So from this one, the answer key was wrong for this. So if he was then saving this after 4 months, his graph then would have to have gone down to $0 at 5 months. So here is where his graph would be, and it would be at $0 at 5 months because we would have to represent that he doesn't have anything left in that bank account. So his graph, the graph for that number 5 would look something like this. All right, so for this one, it costs $25 to rent a car and 10 cents for every kilometer you drive. Create a graph for the scenario And even if you do not drive the car off the lot, it will still cost you $25. That's why with 0 kilometers, it's still $25. So what we need to do then is figure out, well, how much is he going, or how much would this person pay if they traveled 10 kilometers? Well, they're being charged 10 cents for every kilometer. So if we did 10 cents times 10, that gives me 1. And they're paying $25 to begin with. So that means that they would pay $26. For 20 kilometers, we would still times that by 10 cents. That's 2 plus 25, which is then 27. For 30 kilometers times 10 cents, that's 3 plus 25, which is now 28. For 40 kilometers, that's 4 plus 25, which is now 29. And for the last one, 50 kilometers, or 50 times 0.1, which is then 5 plus 25, which is then 30. So I'm going to now create my axis. So I'm going to do 10, 20, 30, 40, 40, 50. Let me just make that a little bit neater. So 30, 40, 50, 60, 70, 80, 90, 100. We can choose what we want to count by. And since everything in my X and my distance is going by tens, I'm just counting by tens there. And then for this next one as well, we just want to make sure that we are being consistent in our counting. But since I don't have a lot of y-axes here and everything's counting by 1, I'm just going to draw this little like squiggle here to represent that I'm skipping to 25. And then from there, every single one is just being counted by 1. We need to make sure that we're consistent on our axes. Y and X don't have to be the same compared to each other, but everything that we're counting up in Y needs to be the same, and everything that we're counting up in X needs to be the same. So at 10, we're at 20, or at 0, we're at 25. At 10, 26, 27, 28, 29, and then 30. And since we end there, we could just draw our segment ending there. But I'm going to just continue with it because we know that we could rent it for more. And I'm drawing the arrows. So my graph will have an endpoint here because we can't travel in negative kilometers. So it can't go with an arrow facing this way. But we will draw it with an arrow going in the other direction because we can travel for more than just 50 kilometers. It doesn't say that's what we have to, but we can use this table then to generate the graph. Find a rate of change in this graph. Well, from here, I'm moving up 1 and over 10. So if I'm moving up 1, that's a change of 1. And I'm moving over 10, so it's 10. So 1 over 10, or this 10 cents. 0.1 if you want to raise a decimal. What this represents, it's how much we're being charged, because this is cost and this is distance, so kilometers. So it's how much we're paying per kilometer. What is the y value in this axis, and how does it relate to this scenario? Well, the y value of this axis is our cost. That's telling us how much we are paying at the end. So it's our total cost of our rental. And it relates to the scenario because it's telling us we can like extend this graph out to say, well, at 70, we'd be paying $32. If you pay the same fee, but more per kilometer, what would this look like? Well, it just depends on what you would, like we're creating this scenario. So in my answer key, I just made it so it's 20 cents per kilometer. So I went up 2 and over 1 for all of mine. And that's just representing 20 cents instead of 10 cents. So for this one, it's just you would come up with something that was more than 10 cents and then just create your own graph with it. So then these last questions, this was just like, do you actually understand what slopes and this means? So it's just giving you a context of a problem and seeing, okay, what does it mean in that context? So what is the y-intercept? Well, we know our slope-intercept form is y equals mx plus b. Well, here we don't see y or x, but we can see that there's a t here and there's this f of t. So we can just say, okay, this is what y is equal to, and it's t is just representing the x. So our y-intercept is a number that's being added or subtracted to it. So in this case, it's 1.90. And what does that mean? Well, the function below shows a cost of hamburger with different toppings. So t represents toppings because it says toppings t. So this is how much the hamburger costs if you got 0 toppings on it. So no matter what, you're paying $1.90 for the hamburger. So it's telling us what it costs. So it's when it says, what does it mean? It means in the context of the problem. The slope is the number that's being multiplied to our variable. So it's 1.40 is what our slope is. And it says hamburger with different number of toppings T. So this means how much each topping costs. So it's just saying, can you identify what it means in the context of the problem? And if Jody paid $3.30 for a hamburger, well, that's our final cost. So it'll be 3.30 is equal to 1.90 plus 1.40T. How many toppings? Well, we know that we're not substituting in for toppings because this is how many toppings. So we would have to solve for T. Now it's just solving a regular basic equation. So we would do 3.3 minus 1.9. So we subtract 1.9 from both sides. So we get 1.4 is equal to 1.4T, and now we just need to divide by 1.4, and that means that T is equal to 1, or they got one topping in order for it to be $3.30. All right, so the same thing is for each of these. For this one as well, what is the y-intercept? Well, it's the number that's being added or subtracted, so it's 2.25. And what does it mean? Well, it says the function shows the cost of an ice cream sundae with different number of toppings T. So once again, this is how much the ice cream costs before we get any toppings. So the ice cream sundae just plain is $2.25. The slope is the number that's being multiplied to our variable, in this case T, so it's 0.75. And what does it mean? Well, that's how much each topping costs. And then if they paid $6 for a sundae, how many toppings? Well, 6 is equal to 2.25 plus 0.75T. Well, we would then do 6 minus 2.25, which is then going to give me 3.75. So minus 2.25 from both sides. This is solving a basic equation. So 3.75 is equal to 0.75T. We divide each side by 0.75. And when we divide it by 0.75, we see that T was equal to 5. So that means that they must have got 5 toppings on that sundae. All right, so for number 5, it says the graph below shows the number of newspapers delivered and the total pay for Leona's newspaper delivery job. What does the slope of this graph represent? So once again, we know our vertical axis is our y. We know our x, our horizontal is our x. So we represent our slope by changing y over changing x. So it says y vertical is total pay. And the denominator, or the x, is our newspaper delivered. So what our slope represents is how much money we are getting paid for our newspapers that we're delivering. So it represents the total pay for every newspaper that we deliver. And we can then find our slope if we really wanted to. Here, it doesn't tell us to actually find the slope. It just says, what does it represent? So here we went up 5. And here we go over 220. So we can then reduce this to say that this is equal to 1/4. Or we can write it as 0.25, which means that we get paid 25 cents for every newspaper that we deliver. And the last one, number 7, Colby puts 100 in the savings account. The graph below shows how the amount in the account will increase over the next 10 years. What does the y-intercept represent? Well, that's our starting point. So that is how much money they put into the savings account. So there's really nothing that we need to do for that. Remember, y-intercept is where we're at 0. So our x is 0. So our point is 0, 100. So that means that when no time has passed, we have $100 in there. So that's how much money they put into the savings account. Right? That is it for this.